Hello, I'm Athara Kukkar, and this is my project on ROS. So these are the contents of my project, the motivation of my project, the basic overview, the tasks, the challenges what I faced. Then I'll head on to the demo and the future scope of the project. So my motivation for this project is from F1 racing. I'm a huge fan of F1, and in F1 races, there's a pit window where the drivers come in to change the tires. If you can see the video, you can see how they change the tires in a fraction of a second. But changing of tires is not just a task carried out in F1. It's also carried out in manufacturing industries where it requires human labor and a lot of time. If you can see this video, might be able to understand how much time is required for a human to go near the tire bolts, remove the bolts, and it also requires a lot of human force. Removing each and every bolt so many times is a repetitive task which can prolong the manufacturing process. So I have created a Amica Panda robot simulation which goes near the wheel, removes the bolts in a methodical manner with a twisting motion and places it on a table beside. So these are the processes that the robot carries out. So we start with the MoveIt Panda motion planning. Then there are 12 positions it has to be carried out, and it, during these motions, it has to detach and place the bolts on a different area other than the wheel. It ensures that there is no collision with any other part, like the bolts kept previously on the table. The These are the challenges that I faced during the project. So the first was the planning failure. So initially, when I was planning out the path of the robot, there were many instances where the robot's trajectory was moving haphazardly. It wasn't a smooth trajectory. It was shifting from one specific angle to other instantly, which was causing failures. The second part was integration of STL files. The STL file is not easily accessible in the MoveIt repository. So I had to actually download and design a small wheel, which I was able to then import into the MoveIt scenario. I also learned about the object manipulation and with motion planning when I was actually placing the bolts on the table beside. The collision handling is the learnings from with motion planning, which made me understand how the motion planning actually works. Now let's move on to the demo. So these are the four commands that I actually run after uh, after we have all the files in the places. When we started, first we launched the Move It Panda demo, which opens the Amica Panda robot. I just changed the angle of the uh, robot view so that we can see the tire and the box where it places the bolts. So this is the command to add the box. I have kept it as a separate script so that I can easily manipulate and change the code, or if I want to add any other asset or any different design, I can use that. Then the next is the add the tire design to the move it configuration. So this is the tire design which I had, which a part of it I downloaded from the internet and also designed the small bolts over here. This is rather than the whole tire, it's the main part of the rim which I need for my project. And then we start with the motion planner, which actually executes the motion. If you can see, the robot moves on forward near the bolt, and while moving backwards, it also carries out a twisting motion, which removes the bolt from its actual place. I wasn't able to create a different uh, STL file to remove the bolts actually from the wheel, because that requires a intense amount of solid model designing, and we are dedicated to ROS programming. You can see down here the robot places the uh, bolts imitated down over here on the table, and the twisting motion is carried out linearly in the backward direction so that there is no shear in the bolts over there, shear breakdown. This is my demo of the project. Now, what more can we improve in this project? So we can add dynamic obstacle avoidance so that if there are any other dynamic collision objects in the environment, they can be handled easily. We can implement a vision system which can incorporate cameras to detect the bolt's position so that it actually has a precise location rather than us giving a mm, coordinates of the robot. Then advanced gripping mechanism. So we can also add a different end effector gripper to increase the efficiency and also make sure that there are no failures while ungripping or unscrewing the bolt. The last thing I think we can do is add multiple robots to manage the screws or any other different assets, like the actual moving the actual tire somewhere else on the workstation. So I think I have successfully completed the demonstration and planning and manipulation of objects. I think the four screws or like many more which can be included is one of the main key points of my project. And as per the assignments and learned in the previous uh, four assignments, I think I have successfully completed and managed to do this project on my own. Thank you so much.